Okay, picking up where we left off, I had just finished the left column. Now I need to deal with the middle column. Now I don't want a 1 on the top this time because I already have my x isolated. I need my y isolated. So I need to get 1 here in the middle. So I'm going to take row 2 and divide it by -5, just like, because that's the easiest thing to do. They're all multiples of -5. So again, my row 1 and row 3 don't change. When I divide it by -5, I get 0, 1, 1, 0. I can now use this one to clear out the rest of the column. So to clear out row 1, I'll take row 1 minus 3 times row 2. So because I need to multiply this by 3, you can also multiply it by -3 and add it. It's totally fine. My last 2 rows don't change here. Doesn't matter what I multiply 0 by when I'm subtracting it off. 3 minus 3 times 1 is 0. That's the whole goal. 2 minus 3 times 1, so 2 minus 3 is a -1, and this is still 1. I need to do the same thing with row 3. So here I want to do row 3 plus 2 row 2 because it's negative. So we need to add. Row 1 will not change. Row 2 will not change. Row 3 is going to change. 0 plus 2 times 0 is still 0. This one's now 0 because it's -2 plus +2. -1 plus 2 times 1, so -1 plus 2 is 1. 1 plus 0 is 1. Okay, now that the second column is done, I'm just focused on the third column. I want to get a 1 in the bottom right, which I already have, so there's no multiplying or dividing there. So we get to kind of skip that step. So what this really tells me here is z equals 1, which we already knew from solving this problem before. But again, I need to get the rest of the terms to 0. So row 1 needs to add row 3. Nothing else changes. 1, 0, now 0. 1 plus 1 is 2. Now to 0 at row 2, I need row 2 minus row 3. Nothing else changes. Row 2 minus row 3, we have 0 minus 0, 1 minus 0, 1 minus 1 is 0. 0 minus 1 is -1. Okay, once your left side is at 1 all across the diagonal, what's left over here is your solution set for x, y, and z. So that'd be 2, -1, 1. Which is the same answer we got before, which shows it works. You may argue that this is not ideal to do by hand, but your calculator, this is how it actually solves systems of equations. And there are matrices in the calculator that you can put in, which can do this for you. Now let's see what happens, what we can do to solve other equations, or maybe what happens when it doesn't have an ideal solution. Solve 2x minus 3y plus 4z equals 6. X minus 2y, so it's a system of 3 equations. If there's a missing letter, you put a 0 in. So we've got 2, -3, 4, 6, 1, -2, 1, 9, 0, 1, 2, -12. This one could be unpleasant. We'll see here. So we're going to divide row 1 by 2 to get 1, -3 halves, 2, 3. -2, 1, 9, 0, 1, 2, -12. There's already a 0 in the last row, so I only need to clear the second row. So row 2 minus row 1. Again, the other two don't change, so I'm just going to fill them in now. 0 here. -2 minus -3 halves, so -2 plus 3 halves is -1/2. 1 minus 2 is -1. 9 minus 3 is 6. And I need to fix the second one. To get rid of a negative 1/2, I need to take row 2 and multiply it by negative 2. When I do that, negative 1/2 times negative 2 is 1. Negative 1 times negative 2 is 2. 6 times negative 2 is negative 12. To clean up the rest, I have to do row 3. We'll do row 1. To clean up row 1, I'm going to have to add 3/2 of row 2. It's kind of gross to most of you, fraction-wise, but it's fine for us for now. 3/2, well, that should be 0. 3/2 of 2 is 3. 2 plus 3 is 5. 3/2 of negative 12 is negative 18. Negative 18 plus 3 is negative 15. To clean up row 3, need to do row 3 minus row 2. Okay, so when I add row 3 minus row 2, though, this became 0, and this one became 0, and this one became 0 when I added them. So what are these equations? Okay, so when you get a whole thing zeroed out, if you get a bunch of zeros and a number on this side, that's no solution. But when you get a bunch of zeros and a 0 on that side, this is the free variable. So what do these equations really translate into? X plus 5z equals negative 15. And y plus 2z equals negative 12. You'll notice here, that means once the row is gone, that's like my z is my free variable. And the others are going to depend on z. So what is y in terms of z? It's negative 2z minus 12 by moving the z over. X is negative 5z minus 15. So what we could do in our solution set is, we have negative 5z minus 15, negative 2z minus 12, and then z gets to be whatever it wants. The rest will adjust. So this is what it looks like if there's not a nice single solution and you're using the matrices. Some of you are like thinking, well, I'd really rather it zero out. That way I can stop doing this process. Perhaps a fair point, but either way you should still be able to handle it. And then we'll do an application problem in the next video.